So the classification one is done. So in that one we have seen the basic data types and advanced data types are done. So and we have seen the implementation part also. Okay, for both. Now let us see the classification two. Okay, what the classification two means. So it's also very interesting, guys. Okay, so what is the thing is. So in this one also. The two types are there. Data types are data types are of two types. You can say two types. So two types. One is called as immutable, and what is the immutable means, and the second one is like a mutable. Okay, mutable. So immutable means, so let us understand what is the mutable and immutable. Okay, it is taking that thing, right? Okay. So immutable means, so we cannot we cannot able to modify modify. Okay, so we cannot able to modify data. Okay, so within the same address. So for these two statements we can say, so hard keyword, we can say hard keyword like a the major keyword is same address, within the same address. So in the interview, if you say simply define, okay, we cannot able to modify the data means, so it is incomplete. You have to specify the within the same address. Okay, so that is a immutable means. So mutable means, so it's the opposite of we can able to modify data within the same address. Okay, in the same address. So this is a, so immutable means unmutable. Okay, so immutable means we cannot able to modify the data within the same address. So mutable means we can able to modify the data within the same address. Okay, so let us understand the what is the exactly meaning of the mutable and immutable. Okay, so we will see the intuition behind the each one. Okay, these things. So let me take a simple diagram for this thing, data table. Okay, I will take this thing. Okay, so one second, it is opening. So data underscore types. So it is creating. Actually, we do have the data, old one, right? Okay, no issue. I will take this thing. So this is a, now let us see what is the differentiate between the immutable and mutable. Okay, so immutable and mutable. Now if I take this copy and paste it here, paste it here. So first of all, let me draw a line. So it is for, okay, it is for okay, immutable. Copy paste. It is for mutable. Okay, mutable. Okay, so let me zoom it out somewhat. Okay. So first of all, let us understand immutable means. So we cannot able to modify the data within the same address, right? Immutable means. So what exactly it is for example. Okay. So exactly, for example, I am telling that, for example, a equals to 10. For example, defining a variable a equals 10. Okay, so we know the impact of this line will be, so there will be a memory allocation for this thing, right? So we will be having the value 10 here, value 10. Okay, so now the value 10 will be here, and our variable a will be representing towards the, okay, towards value 10. So we have understood this thing in the previous class only, I think. Okay, first class itself. So a is the thing representing the value 10. So if I give one more variable, a equals to 20 now. Okay, so a equals 20 means if I keep a equals to in place of 10, if I keep so what exactly I'm trying to do? Exactly, I'm trying to do. I'm taking the same variable a. So here also a is there. Here also a is the same variable, but I'm changing the value only. Okay. So what exactly immutable means? Immutable means, So we know this thing. For this one, we're having address like a double one, double two, double three, double four. So one memory address will be there for this thing. Okay, for so for variable a, I mean having value 10. So address will be double one, double two, double three. Now we know this thing a is equal 20 means, so there will be a one more memory allocation will be there, right? So it is not a cannot able to change there itself. It is changing the one more memory. Okay, now value is 20, even though variable same, but it is taking the one more memory allocation. Let us take so double four, double five, double six, double seven. Okay, so now the impact of this line will be, so a is stopping towards representing towards the value 10, and it will start representing the value 20 here. Okay, value 20 here. So that is the meaning of the, okay, immutable. So tell me, sir, so okay, first of all you create the a is equal 10. Okay, 10 is there, memory allocation is fine. So now again you have created the variable a is equal 20. Now there is one more memory allocation having the different address. Okay, now a is stopping towards the value 10 and it started representing the value 20. Now what will happen to this 10 again? So it will consider our Python, okay, interpreter will consider this 10 value as a our what it is, inactive variable. So it will be flushed. Okay, so it will be flushed or cleaned, we can say. Okay, so we're having a concept called as a garbage collector. So garbage collector is, so his responsibility is to, so what is that, flush the clean the inactive variables. Okay, for the value 10 there is nobody, nothing is representing value 10 here. It is like a dumb fellow, so simple like sitting alone. Okay, so inactive person. So that is the reason. Okay, our what is that, garbage collector will flush this value 10. So this is the things will be happening in the, okay, immutable means. Okay, so that is the understanding, right? Now, so this is the intuition behind the immutable means. So let us take what is the mutable now. Okay, what is the mutable first of all? So mutable means we can able to say, so example for the mutable means, so let us define list actually. When I'm defining the list LST, okay, list here, I'm taking the some values like so 1, 2, 3, 4, 5, up to 5 values I'm taking the list. Okay, so 5 values I can able to take in the list. So here if I write one more thing here, print not print, exact print, okay, okay, the allocation will be, so I mean the impact of this line will be what, so there will be a memory allocation for this thing, right? So I will be taking the memory, one more new memory here. Okay, new memory. So in this one we are having a list of values. Okay, lst is equal to list of values. Okay, list of values. So this thing we know already. Okay, this thing we know. So the memory allocated will be, so for this thing also having the some address. So for example address like a, so double seven, double eight, double nine, and double three. Okay, some memory address will be there for the this complete box. Okay, for the list of values. So now let me remove this thing. Now there is a mutable means, but actually mutable means we can able to modify the data within the same address, right? Okay, now I will take, okay, one what it is, method is there in the list actually, that is called as a append method. Append method functionality is something like it will add the values in the end of the list. So let me show you. So I'm taking the lst is a variable, dot append is a method. So I would like to add 6 value in the at the end of the our existing list. Okay, so this is a one more thing. Okay, appending method is responsibility is, functionality is simply adding the value 6 to the end of the list. That means, so what exactly happening here is, so when we print this thing we can able to get so we can able to get 1 second. So now value 6 will be added here. So now it is not taking the one more memory address, but it in the within the same address only, same box only, it can able to modify the things. Okay, so if you read one more time the definition, immutable means we cannot able to modify the data within the same address. So if you see in this is the same address, right? When we given the when we took the same variable a, first case we given the a is equal 10, and second case we given the a is equal 20. It is not modifying the taking the value at the same double one, double two, double three, double four location. It is taking the new memory location again. Okay, within the same address we cannot able to modify same thing, anything, right? Or data, right? So that is called as immutable data. Okay, so that is a immutable means. Mutable means, so we can able to modify the data within the same address. So within the same address only, 7788 9933 memory allocation only, I can able to modify the things. So initially 1 2 3 4 5 values are there. Now I can able to add one more value 6. That means I can able to modify the hour list within the same address. That is called as a mutable nature. Have you understood what is the nature of the immutable and mutable?
Yeah, sir. Yes.
మీకు అర్థమైందా ఇద్దరికి?
Yes, yes.
Yeah, great. Yeah. So, so tell me, sir, what are the examples for the okay mutable and immutable? So first of all, let us take immutable. So tell me any examples. So we can take all our fundamental data types. Let us take integer, float, okay, our complex, boolean value. So come next one is bool come strings, okay, strings, plus along this one, so there is a one more okay thing that is like a tuple. So tuple, so all fundamental data types plus tuple we know it is a collection data type. If you remember, it is a collection data type. So tuple is like a collection. If you see collection data type or advanced data type, we can say. So all basic or fundamental data types plus tuple. Tuple also, guys, we cannot able to modify. Anyway, I will be demonstrating the things in the while discussing the tuple concept. So as of now, it is a it is the examples. Now tell me what are the examples for the mutable okay, data types? Tell me example.
List,
List is a one,
set,
set is a one more thing, and
and I think dictionary.
dictionary. So these are the come under the our so examples of the our mutable things. Okay. Now tell me in the real time which data types will be more useful, mutable or
Mutable,
immutable?
mutable
Mutable, right?
data
Why?
types. Yeah.
Because there's more customization is there. We can able to
Yes.
customize.
Mm.
Okay, so immutable means rarely for defining the variables we will be using, but so most of the time we will be using the mutable things in the our in the real time. Okay, so okay, sir, we have understood theoretically, but what about implementation part? So let us see the implementation part for the immutable and mutable. Okay, so let me take anaconda prompt. 1 second. Documents, AI, bootcamp, and generative AI. So data types. Okay, so in this one, let us discuss about first of all immutable. So ఇవన్నీ మనకు తెలుసు. Next one we will see what is a immutable. Immutable. Okay, so let me make it as a markdown for better visibility. Now I'm defining the a equals to 10, for example. Okay, if I print a, okay, and let us see the what is the okay address. We have to see the address, right? So id is a one function which will help us to show the address, okay, address of the variable a. If I execute this thing, you can able to get 10 is our value at 147117653 double five double two four. This is the memory location of the our variable a, right? So that is the thing we already know. Now same variable a, this time I'm taking the variable value 20. So if I copy paste the same thing here, now let us see the or output. If I execute this thing, so 1 4, so here double five double four double two four is there, here triple five double four is there, which are not same. So as per our understanding of the concept intuition, so immutable means so when we give the a is equal to 10, so this is the one more memory address. Again a is equal to 20 means it is taking the one more memory address. Okay, can you able to see here? So same thing we can able to here see here. It is taken the means which is not cannot able to modify within the same address. ఈ మెమరీ అడ్రస్ లో అది చేంజ్ అయిపోతుంది. సో దాని బదులు ఇంకొక అడ్రస్ తీసుకుంటుంది. ఇట్ ఈస్ ఆక్యుపైయింగ్ వన్ మోర్ అడ్రస్. Okay, so that is called as the immutable nature. Okay, then what about mutable nature means? So I will take so mutable now, mutable. Okay, so mutable, and let me make it as a markdown and execute this thing. So now I will take one list of values. A is equal to so 1 comma 2 comma 3 comma 4 and 5. Okay, so this is our list. Okay, original list. If I print okay, if I print A means I will get the so 1 2 3 4 5 values. Okay, so now I would like to see the what is the in which location, memory location this a variable is stored. So now for this thing, same thing, id is our function, or we can say method, which will display the address of the our variable. Okay, now if I execute this thing, you can able to see our list is all located in the 1889533221696. In this location our variable a, which is list, is allocated. Okay, now if I separate these things, now let us see. Okay, so intentionally I'm separating these things. Okay, now what I'm trying to do here, ఇక్కడ ఏం చేస్తున్నాను, so I told you append method, right? Append method means which will add value to the at the end of the list. Okay, so I will take lst is the lister. Okay, sorry, lst a is the list, actually a is the lister. Okay, now append is a method. Append is a method. Okay, now I'm adding the value 6 here. Okay, so I'm adding the value 6 here. So this six value will be added at the end of the our list. Okay, now we have to, okay, so you're adding the value 6, right? So let me show the thing here. So I'm printing again list here, and also I'm checking that after modification of the our list, is it taking the same address or it is taking the different address. So let us check that thing. Okay, so if I execute here, guys, so it is the original one. So before means 1 2 3 4 5 is the original one. So this is a memory allocation address. And second thing is I'm taking the separation here. Okay, append 6 means it is appending the 1 2 3 4 5 6. Okay, this updated list actually. And if you see the address of the updated list is same. So this memory allocation, this memory address, and this memory address are both are same. Okay, so within the same address only we can able to, okay, modify the values. So that is called as a so mutable nature. Within the same memory allocation we cannot able to modify the our values or data. Okay, that is called as a immutable nature for sure, guys. Okay, gunshot question in the interview. Okay, for sure. So that is the understanding of the so mutable nature and immutable nature. So anyway, I will be discussing in depth for the so strings. I will discuss for the something like a list tuple. So how why, I mean, we will demonstrate the, I mean, tuple is a immutable one kind of thing. Okay, so we will demonstrate in the upcoming classes. Okay, so మీకు అర్థమైందా సాయి అండ్ గీతాంజలి?
Yes, sir.
Okay, so that is the understanding of the these things. Okay, that is the understanding of these things. Okay, so we have understood clearly what is so classification data types. Advanced classification 1 and classification 2 is done, right? So done. Now Okay, if we are done with these things, let us go for the our next concept is data types. Data, not data types. So rules to create rules to create, okay, variables. Okay, so from the starting onwards, we are trying to create the variables with simple names only we are creating. So now there are some rules are there. So to create variables, let us see the those rules of the variables. Okay, after that one we will go to the type conversions. Now let me take a new notebook for this thing. So let me take a new notebook. Yeah, సెషన్ రికార్డ్ అవుతుందండి.
Yes.
అవుతుంది కదా.
Yes, yes.
ఓకే రైట్. Okay, now rules. So variable rules. Okay, now let us take this thing. So I will divide these things into two things. Like a, so legal variables. Okay, legal variables. Okay, and second one is like a illegal variables. Illegal variables. Okay, so let us start with the legal variables first of all. Okay, so my var, for example, I'm taking my variable. I'm taking, for example, name as let us take so very good, Ronaldo. Let us take Ronaldo. Okay, Ronaldo. So let us take Ronaldo as a name. I'm taking this thing. Okay, so if I execute this thing, printer, okay, my var. Okay, my var. If I execute this thing, I can able to get the output Ronaldo. Okay, so next thing is, so there is a one legal variable. So I can use the my underscore var. I can use the only one special character underscore only for representing this thing. So my var. Okay, so my underscore var I can able to use. So my underscore var, if I execute this thing, I can able to get the output. Okay, so or else, mm, I can take this thing. You will confuse here. 1 second. One second, please. Yeah, okay. Now the legal variables. I'm taking the my var. So again, I will take this thing into new cell actually. Okay, and X and execute this thing, and let me create more cells under this thing. Okay. So now I will take one more thing, my var. So my underscore var Ronaldo. If I print again my var again here, so you can able to get the same output. Okay, my var. So it also we will get the same output Ronaldo. So there's one more way is I can use the, so underscore, for example, underscore my underscore var. So in front of this thing I can able to use the two things like my variable. If I execute this thing, okay, if I execute here and let me print so this same thing. Okay, if I execute here, you can able to get the execute a clear execution. Okay, I mean there is no doubt in this thing. We can use the underscore in front of these things. Okay, so next one, can I use the combination of the uppercase and lowercase? Of course, we can use my capital VAR. Okay, I can able to use the combination of the uppercase and lowercase. So same thing if I paste it here. Okay, or let us take Ronaldo. Okay, if I print so my underscore capital var, if I execute this thing, so there is no problem, we can able to get the output. Okay, so I can completely I can use the my var as a caps. Okay, my var as a caps I can use, and in place of this thing, so same thing, for example, listen Kohli is the name, for example Kohli. So now print my underscore var, for example my var. Okay, if I execute this thing, Kohli can able to, so there is no doubt in this thing. Okay, so I can able to use the combination of the so characters and the numerical values. For example, my var, for example, 2. Okay, so my var underscore 2. This time I will define Rohit Sharma. Okay, Rohit. So if I print my var 2, if I execute here, you can able to get the output Rohit, right? So guys, this is a way, these are the possible legal ways are there, legal variables are there we can use. So we are having the like illegal variables, we are having the illegal variables which are not possible to use. For example, I cannot use the numerical value as a friend. Okay, if I use the, so for example, we can take okay, for example, Sai. Okay, if I print this thing, okay, to my var, right? If I execute this thing, so there is the invalid decimal literal, so we cannot use the 2, I mean any numerical value in front of the variable. Okay, you can use the in between also. Okay guys, so in this one, if I execute this thing, let me open the, so in the legal variable, still we can able to use not only in the front, we can use in the, so for example, one here I'm giving, so here also I will give one. So in the combination we can able to use, there is no problem. But in front of, so starting only you cannot give the your what is the numerical value as a your variable name. Okay, that's the one problem. So and also we cannot use a special except underscore, we cannot use the special character as a our I mean creating our variable. For example, my hyphen var, if I give that so for example, I can give the something different name. Okay, so for example, okay, Bumrah. Okay, Bumrah. So if I print my, okay, under my hyphen var, right? If I execute this thing, so there is a problem, so cannot assign to expression here, maybe you may, so it is thinking different way. So and also I cannot use the special character also. Okay, if I take these are special character, so if I use the at the date also, actually in place of hyphen, if I use at the date or hash, so at the date, and also if I, in this one also I will use the, I can print same thing. If I execute this thing, since there is a problem. Okay, so and also last one, we cannot use the my var, we should not use the white space also. Okay, so we can take our players are there, who is that, anything is, okay, okay, so what is that name we can take, so what is the thing guys, okay, Dhoni for example.
Dhoni.
Now names are not getting remember. Okay, so printer, so without a name, so my var. So if I give here, if I execute this thing, this time also I cannot able to find out the, so proper I mean proper execution here. So these are the, I mean I'm keeping these things like this only. Why? Because while practicing, you can able to see. I mean after some days also, if you see this notebook, you can able to easily identify that what's the problem. Okay. So that is the reason I classified between the legal variables and illegal variables. So legal variable means these are illegal variables means you should not use the special characters, you should not use the numerical values at the front, and you should not use the white spaces kind of thing. And also in the legal variables means, and suggestion is, so use a meaningful name. Okay, meaningful name. So for example, you are defining something, for example, a is equal to, for example, if you want to define your some string is there, for example any kind of text, so you are defining in the a variable, okay, which is not good. Okay, so for example, phone number means write the phone number, phone number is a variable, for example I'm telling you. Okay, example say I'm telling you, so phone number, then you can write the phone number in this thing. So for the phone number, don't define a is equal to phone number. Okay, a is equal to, so for example 93464 something kind of number. Okay, even though name is too much long, use the meaningful name only while assigning the variables. Okay, so that is the understanding of the, so legal variables and illegal variables. So next one, we're having a type conversions are there, so we'll be discussing the type conversions in the tomorrow's class. Okay, type conversions in Nainka, so type conversions, these are very very interesting type conversions. Okay, so that is the understanding of the type, I mean type conversions రేపు చూద్దాము. So type conversions అంటే integers float numbers ఇవన్నీ ఉన్నాయి కదా, so we can able to convert integer to float, float to integer, integer to string, string to integer, like that we can able to convert. So that will be will be seen in the tomorrow's class.
Okay.
Okay. Meanwhile, I will share the so what is that some articles on this the variable rules on these things, so you can able to go to that thing. Okay. Yeah.
Okay. Sure.